All right. And with that, we should be live. Yeah. Hey, folks. Hello and welcome to another Service Mesh Academy. I am Jason. I'll be your host, MC, whatever. And we've got Flynn doing another excellent presentation on this time, Flynn, we're talking about.
This time we're talking about Linkerd in production, but updated for 2.13. I love the way you say excellent presentation when you haven't even seen it yet.
I just have that much confidence in you.
Always nice when one's coworkers have confidence in one.
Yeah. You are, however, a little bit faint.
Am I? Interesting. Yeah. Is that better?
That's way better. It's excellent.
All right.
Maybe it's just my bad ears, but there we go.
Whatever.
Yeah, so we like to take a couple minutes at the start just to say hello to everybody. So if you're there, Flynn's going to post some links, but we've got a Slack we'd love you to join us on, specifically as we go through. So we go through some of the demo scenarios and some of the slides. If you have questions, we have folks waiting in that workshops channel in Slack, ready to answer questions. We can also answer questions live in chat as we go. Love to start by hearing where folks from, like where are you joining us from, just so we can say hello. I'm in Virginia in the United States. And Flynn, where are you at?
I'm outside Boston. I somehow did not realize you were actually in Virginia instead of Maryland. I don't know why. But okay, now I know.
Yeah.
I was also going to point out that general Linkerd questions, we've got the Linkerd 2 channel on the Linkerd Slack. In a minute, I'll put the workshop channel back up just in case anybody missed that.
Yeah, awesome. Thank you. All right, we have Ahmed. Good to see you. Thanks for joining us. We have someone
Cairo.
from Munich in Germany. Is that the way you say that?
München. München, or something like that.
Munich is way over my head with that one. That doesn't that doesn't work for me. But
I'm sure I don't actually know how to pronounce Cairo's name either. But I've always said Cairo, unless
I've always thought it was Cairo. Yeah.
Yeah, there's also one in Illinois, maybe in the U.S.
Yeah.
That one's pronounced Cairo, although it's spelled the same way.
The Midwest has a bunch of interesting names for places. Like you can be very disappointed by going to the wrong Paris.
yes, you can. There's a Paris in Maine, actually, very close to here. We drive past it all the time on our way up to ski at one of these places. Okay. Right. Oh, Ahmed says we're correct. That it is Cairo. Nice. Good to know. All right. Let me flip back to the workshop one here. Figure we can keep doing this for another minute or so. We do have a fair amount of stuff on this one, so we should get started fairly soon, but that's okay.
Yeah, what the heck? Let's dive right into it. Oh, hello from Lisbon, or hello to Lisbon.
Yep. Hi, Lisbon. All right. Let's go ahead and get this started then. I'm going to drop that. Come back over here. Everybody can see that, right? Jason, can you see that?
I can, yeah.
Excellent. All right. So, yeah, this is, like we said, this is Linkerd in Production 101, specially updated for 2.13 Linkerd. Honestly, it didn't take a lot of updating for 2.13, which was kind of nice. It turns out that running things in production is pretty much running things in production. I was really happy to learn that. There are a lot of SMAs where we do a few slides and then we do a lot of demos, and this is not one of those SMAs. We have a lot of slides. The slides have a lot of words. I'm not going to read all the words, don't worry. But the point is that we're trying to arrange it so that you can go back to this slide deck later and have it be a reasonable reference. So you're going to see lots of words, you're going to see lots of links and QR codes and all this stuff. This is why it's kind of a departure from the way we often do these things. Okay, there is a workshop part. Most of the time we say things like, it really doesn't matter what kind of cluster you use. For this one, it matters that you have at least 3 nodes. And we'll talk a little bit about that later, but it must be at least 3 nodes or things will not work and everything will get confused. You'll need the usual kube control bat step, the Linkerd CLI. The QR code on this page will take you to the workshop source if it's easier for you to just scan that, or you could copy and paste it or something. And hey, Jason, thank you for putting that in the workshops channel on Slack. I appreciate that.
Yeah, no problem.
All right. Let's see. There is stuff in there to go ahead and set up a cluster for you, or rather to set up your cluster once you've created a cluster. Make sure you're using an empty cluster. It will try to check a little bit, but I'm sure that check is very fragile. Please do not run this against your actual production cluster. It will trash it and you will be very unhappy. Use an empty cluster. If you want to do this the simplest way possible, which is the way I'm going to do it, pip install demosh, and then you can just run demosh on the README and you'll see that going on, but that will take care of all the checks and making sure you've got all the requirements and all that kind of stuff. Okay, the agenda. We're talking about getting Linkerd into production. We're going to spend most of our time going over kind of a checklist of things that you need to look at and then digging into some of the details. And then we're going to go into the workshop. I am personally interested to see how much time we need for the slides and how much we get through in the workshop. So everybody, it'll be fun to see how that plays out. Things not on the agenda. This actually, it does not work to try to do a single Service Mesh Academy episode where we do a deep dive over everything. So in particular, we'll mention certificate management, but we're not going to dig into all the details. We're not going to talk about Ingress at all. We'll mention a couple of things about policy and such, but mostly what we're going to be doing is having links out to other Service Mesh Academy episodes or other resources so you can go and check out the deep dive on those on your own. Here, we want to talk about sort of the high-level things to worry about with respect to production use of Linkerd. And as always, this is probably a good time to point out as well that if you have questions, you can put them in the chat. Putting them in the workshop chat on Slack is the easiest. I'm pretty sure that if you're watching this on some other medium like YouTube or Twitch or whatever, and it has comments, that we'll see those eventually, but we'll see them much more quickly in the workshops channel. Things we assume. We assume that you're already basically comfortable with Kubernetes. We're not really going to be talking a lot about the details of kube. Likewise, we're going to assume that you're familiar with kubectl and Linkerd because this is not really a total beginner course. As I mentioned earlier, we're going to be linking out to a lot of resources, so you probably don't need to panic about that, but there's a lot of information to cover. All right. Before we get into demos versus production, Jason, you have anything you've noticed or anything
No,
you want to comment on so far?
We've got a nice diverse audience. We've got people from New York, California, more people from Germany, and someone from Italy. So
Nice.
Good to see y'all, and thanks for joining us. If you have questions, folks, please do put them in as they come up, and I'll stop Flynn and make him answer anything that makes sense to do as we go.
Sounds good. All right. Just to set the stage kind of for the rest of this, when we're talking about demos versus production, demos typically will be run on a local cluster, possibly on your laptop. Random local K3D kind, something like that is common for demos, really, really uncommon for production. People will typically run production clusters. Well, they'll often run them in a cloud provider, but they'll pretty much always be running them someplace where they're globally reachable and globally routable. That's a difference. Demo clusters don't usually last very long. The cluster that I will be using for this particular workshop has been in existence for maybe 45 minutes, maybe as long as an hour, and it's going to get torn down at the end of the workshop. So it's only going to be around for, a couple hours at most. I've gone through probably about 10 different clusters running through this and getting everything set up correctly. So they don't live long at all, and they shouldn't. Production clusters often are long-lived. We could have a much longer and more entertaining discussion about whether we should allow production clusters to be long-lived or whether we should treat them as completely fungible and just shred them the moment anything looks weird. But people typically don't do that. People typically allow their production clusters to live a long time, might be a better way to put it. If your demo cluster crashes, it's annoying, but it's not a big deal. If your production cluster goes down, it's a very, very big deal. One of the KubeCon topics we've been kicking around is designing for 5 nines. 5 nines of reliability is 20 minutes of downtime per year. So it's a high bar. Demo clusters also don't usually have any particular security needs, where you will typically set them up with self-signed certificates all the way through the trust hierarchy for Linkerd. You don't have to worry about corporate security breathing down your neck. You don't have to worry about auditors. Production, you may well have to worry about both of those things: auditors, corporate security needs, various rules and regulations, and all that. When you are making edits to the configuration of a demo cluster, you typically just run kubectl edit or kubectl apply or whatever. And if you do that in production, your cluster will rapidly get into a state of being uncontrolled, if we want to talk about it in ISO 9001 terms, where you don't actually know what's running and you don't know how to get back to that state if the cluster crashes and has to be rebuilt. These are big problems in production, because typically if your production cluster goes down, you need to get it running again as quickly as possible, right? So if the cluster itself has gotten taken out, you need to rebuild it as quickly as you can. Having a controlled configuration is critical to this, so that you know what the configuration of the thing actually is. And finally, in a demo cluster, if your certificates expire, then the person running the demo gets annoyed. And in a production cluster, if your certificates expire, it leads to downtime, which is a big deal, as we mentioned earlier. I'm going to put Jason on the spot and see if there's anything he wants to add to this particular list.
No, I think that's pretty good.
Cool. All right. So with that, let's talk a little bit about the checklist for running Linkerd in production. I'm going to point out that most of this is drawn heavily from the Buoyant Linkerd production runbook. There's a link there. There's a QR code that will take you to that link. There's some good stuff in there. And with that, let's look at the checklist itself. I'm going to start with, think about your certificates, think about your CNI. And you know what? We'll get to that a little bit later. I don't need to talk about those particular bullet points. Put your configuration in version control. This is critical for knowing what is actually running in your production cluster. Yes, you could do GitOps all the way, but honestly, you don't really have to. There's other stuff you can do there that will get you some of those benefits. Do run in high availability mode. Do run with your own image registry. Do lock down access wherever you can. It's kind of important in production. Definitely set up monitoring and alerting. And you will definitely need to understand how to install and upgrade Linkerd and downgrade it, and how to debug it. My name is covering up part of this, but the shameless plug here would be, we are going to talk a little bit about Buoyant Cloud, because it can make some of this stuff significantly easier for you. All right. Certificates. There is an entire Cloud Native Live presentation only about certificates, and we're going to come back to certificates for next month's XMA, next month's Service Mesh Academy. But the most important thing I want to call out here is the most common reason that we see people actually hit production problems in the real world is that their certificates expire. So don't let that happen to you. Do not be the person who's allowed their certificates to expire. From the security point of view, you really want your Trust Anchor certificate to never be stored, to have its secret key never be stored in your cluster at all. You would much rather have the Trust Anchor cert live off in some off-cluster secret manager, and then have something like Cert Manager rotating identity issuer certificates. We're going to talk a little bit more about that, but only a little bit today. Mostly that's something that you should go back and watch the Cloud Native Live, or even better, come to next month's Service Mesh Academy, and we'll talk about that in more detail. And Jason, for all of this stuff, if there's stuff you want to add from your own experience dealing with production folks, just jump in, or if you see questions, jump in as well.
Yeah, will do. Thanks, Juan.
Think carefully about your CNI. The reality here is that for Linkerd to work, it must go through and tweak the network settings that are inside your cluster so that mesh routing can do its thing. And Linkerd can do this either with an init container or with a CNI plugin. We generally recommend the init container unless you have a reason that you can't use it. That's not to say that the CNI is a horrible thing. It's just to say that there are more ways the CNI in general can break. So if you can use the init container, you probably want to use the init container. If you want more details here, you can go watch the Service Mesh Academy episode on the Linkerd startup process. There's a lot to learn in there. So 2, put your configuration in version control. Do not be hand editing your production cluster. Just don't do it. This is the second most common reason we see things happen with Linkerd in production is somebody made a change, then they forgot about the change, and then somebody makes another change that's incompatible with the first change, but nobody knows the first change happened, so everything just falls apart. If you do not have a controlled configuration, you have no way of finding out who did a given thing and why. And it can be very time consuming to try to figure out what broke the world so you can put it right. GitOps is a great answer here. There's the QR code that will take you back to the Surface Mesh Academy on GitOps and Linkerd. To be candid about this, you can get a long way just by using Helm to manage your configuration and then committing things into Git. We like Helm in particular because the reality of the situation is that the YAML that we publish with Linkerd is tailored for demo environments. It is not tailored for actual production use. It kind of can't be tailored for production use because we don't know what your production situation really is. And you're going to need to make changes because of that. So Helm is better at that than a bunch of the other solutions simply because it ends up being simpler to maintain a values.yaml file than to maintain a script with a bunch of kube control commands or whatever. I was about to point back to the SMA on GitOps and Linkerd, but I did that earlier. So yeah, well, it's still there. You can go look at it. All right. We kind of already talked about this one. Allowing people to make ad hoc changes by hand to your production cluster will get you into trouble. It is not a question of if, it is a question of when it will get you into trouble and of how long it will take you to recover when it gets you into trouble. Don't do that. All right, high availability mode. Linkerd has an HA mode that you can enable when you install with Helm. It is basically all about running multiple replicas of the various control plane components so that we get to avoid single points of failure. This is the reason why I say this workshop requires at least 3 nodes, because HA mode has that requirement for the way it deploys the multiple replicas. Some other things here is that HA mode refuses to allow pods to start running until the proxy injector in the control plane is up and running. That prevents a race condition where a pod that starts really, really quickly, if you start Linkerd in your pod at the same time, a pod that starts really, really quickly could conceivably come up before the injector is ready to apply the proxy, and then that pod won't have MTLS. So HA mode avoids that particular race condition. And HA mode also makes life a little bit easier on Kubernetes by applying some reasonable resource requests. You may need to change the resource requests, just bear that in mind. Documentation for 2.13 HA mode is down there in 2.13 features HA. You can go check that out. A lot of good information there. I mentioned before, there's a gotcha here. You must run with at least 3 nodes because of the way we set up anti-affinity. And you must remember to apply the admission webhooks disabled label onto the kube system namespace so that HA mode doesn't try to do anything silly with the kube system namespace. Things to remember. Okay. Your own image registry. Linkerd actually only publishes images to one registry. We published to GHCR. We've had good luck with GHCR. It's done reasonable things for us. Occasionally it goes down. If it goes down, it's not a big deal until you have a pod that needs to start and has set image pull policy to always, and then suddenly your pod won't come back up. If you run your own image registry, then all of this can be kept under your control. It does mean you have to go to the headache of running your own image registry. But if you're running Linkerd in production, and really if you're running anything in Kubernetes in production, ideally you'll be doing this with your own image registry. You can make it a little bit easier. There are ways of setting up registries as pull-through caches. But yeah, this is a good thing in production. We have documentation on how to set up Linkerd to use your own private Docker registry. It's not that bad, really. It's just not. So you can go ahead and do that. Jason, it looked like you were about to say something, or were you just nodding emphatically?
And just nodding emphatically, right?
Awesome.
Great practice.
Cool. Okay. Lockdown access wherever you can. This one often, in my experience, I feel like this one gets missed a lot. Some of this, I think, is that the tools to really do a good job with locking down access have matured more slowly than Kubernetes in general. At this point, we have pretty good tools for this, which is great. This is pretty much an expression of the principle of least privilege. The example I've chosen here is, the microservice that's serving HTML to the web servers to provide the UI probably is not a thing that needs to be able to talk to the user, talk to the service that would allow it to check the user's bank balance or transfer money or whatever. It probably doesn't need to have access to any other service in the cluster, actually. So this is a thing that often gets missed and can be really, really useful in production. If you know that a given microservice cannot talk to a given other microservice, you don't have to check it for bugs when things start behaving weirdly. There are a couple of ways you can do this. The simplest one for my money is the one that we used in the SMA on Linkerd 2.12 route-based policy. Lock down the whole namespace at first, and then open things up until you got everything working. Obviously, you would be doing this in a place that isn't production at first, right? Right? Sure, everybody would do that, not in production at first. Another point here is that Linkerd Viz profile can actually write you a service profile based on what traffic it sees in your cluster. You should consider that service profile a starting point, both in the sense that a request that it doesn't happen to see while it's monitoring to write the service profile is going to get missed, and in the sense that if you want to do route-based policy, then you need to do that with an HTTP route instead of a service profile, but it's still a very useful place to start. And again, we covered this one in the Service Mesh Academy episode on Linkerd's route-based policy. All right, monitoring and alerting. The most important thing here is do not use the Linkerd Viz Prometheus in production. When you install Linkerd Viz, unless you take specific steps otherwise, it will set up its own Prometheus. That Prometheus keeps all of your metrics in RAM. As soon as that Prometheus restarts, then bad things will happen. My camera has just gone away. That's delightful. So do not, let me repeat that, do not use the Linkerd Viz installed Prometheus in production. My camera might have just decided to die for a little while. I'm just going to go on and be a black screen with an F and a parenthesis for a little while. And at some point, I'll see if I can play with some cables and get it back. But I'm not going to worry about it right now. Because let's face it, nobody's really looking at me. They're just listening to the sound of my voice, as depressing as that is.
The soothing sound of your voice as opposed to the hair flicks. All right, I'll take it.
Yeah, exactly. I mean, I know how much everybody loves the hair flicks. Never mind. Let's just not go there. All right. So yeah, the best home for your metrics is always going to be off cluster. You can use Buoyant Cloud for this. You could use an external Prometheus. You could use Datadog, whatever. There are a lot of different options, but don't use the one that we provide because it is a bad idea. Alerting on various things.
I'll just so Flynn's gone quiet for a minute, so we'll just carry on for a minute. So what he's saying basically is that if you're using Linkerd in production, you need to have a persistent store for the metrics data that comes out of Linkerd. And when you install Linkerd Viz, it uses an in-memory Prometheus, right? Which is only good for a certain amount of time. On top of that, right, when you choose to use Linkerd in production, you're relying on this to be in the critical path for your production applications. So you need to have alerting configured for your control plane and data plane resources, right? So if you have processes that are being, especially Linkerd processes that are being killed, or if your success rates drop below a certain percentage, right? As he says in the slides, we're shooting for 100% basically all the time for the core Linkerd components. You want to make sure that your certificates are being monitored for when are they going to expire. Even if you're using something like Cert Manager, which we'll talk about later, to rotate your certificates, you want to check that that rotation is occurring when it's supposed to, right? Because it's really unfortunate to take an outage related to that. Um, yeah, and you can hit the QR code. Flynn, if you can still hear me, if you can advance the next slide, that'd be really handy. Perfect. Um, so let's talk about installing Linkerd with Helm. It's pretty straightforward. You can, as we mentioned earlier, you can set up your own values file for any particular customizations that you have to Linkerd. That being said, it's worthwhile to always go grab the HA values file. It's gonna set up all the things that you need to install Linkerd in HA mode, right? So that is multiple replicas, that is anti-affinity rules, so that one node going down doesn't take out multiple instances of like destination or whatever that may be. And as you mentioned earlier, it also gives us a policy across our cluster that won't allow pods to start if identity isn't available, right? Which is pretty important if you want to make sure that everything stays in your mesh.
Hey, Jason,
Um,
can you hear me now?
hey, Flynn, I'm hearing
There
you.
we go. All right.
You're a little faint again, however.
You were doing a wonderful job of coping with the fact that my audio paths just decided to die or something. Thank you for that. I appreciate it.
No problem.
This is how you know we're doing this live or something like that. Can you say something again, Jason?
No, I was just saying we'd gotten to
Okay,
the end of this slide, so I think you're ready to move on to the next session.
awesome. Um, I say here that values HA should not need editing. That's possibly not quite correct. Again, you may need to take a look at some of those resource requests just in case. Okay, onward. Understanding how to upgrade Linkerd with Helm. This is a thing you should be doing if you're running Linkerd. You should be keeping Linkerd up to date. Linkerd's purpose in life is to keep your cluster secure, to keep your application secure. It cannot do that job if you don't keep it updated so that it gets all the security fixes you want. So always test, always upgrade. I should have put that first on the list, actually. Yes, do keep Linkerd up to date. Do always test outside your production environments first. And the way that you want to do this one is generally to upgrade the control plane and then to upgrade the data plane. This is a thing that the data plane is designed for. But when you do that, do not skip major versions of Linkerd. So if you're running 2.10.2 and you want to go to 2.13.1, hit 2.10, then 2.11, then 2.12, then 2.13. If you try to go straight from 2.10 to 2.13, bad things are likely to happen. Or maybe it would be more accurate to say, we can make no guarantees of good things happening at that point. If you look at some of the docs, you will tend to see things like https://linkerd.io/2.13/ whatever. You can also just use a 2 in there and it'll take you to the most recent version that we support. So that can be a handy way to save permanent links that should always work, as I've done there. All right. Also, there are a couple of Helm flags that are particularly relevant for upgrading Linkerd, which are the reuse and reset values. And there's this handy little matrix in here that I'm not going to go through because I'm a little concerned about time, but these can be important to get correct when you are doing an upgrade to prevent surprising things from happening. Jason, anything you wanted to add here?
No, just be really confident of your Helm commands, right? Which is kind of a no-brainer for folks that are out there, right? But
Yeah.
getting to know what these things do and how they work is critical for general life in Kubernetes.
Yep. It's just you want to know how your basic tools work is really what it comes down to. And you would like to not be experimenting with this in production. You would really like to be doing this kind of thing in, non-production. Oh, hey, my camera's back again. Awesome. Well, I lift this up so that we can maybe arrange it so it's a little less cluttered now. I guess I moved it while I was making sure it was working again. All right. Like I said, doing this live, folks. Okay. Kind of a variant of understanding how to upgrade Linkerd, you should also understand how to downgrade Linkerd. The first time I ran into this, I saw some of this stuff, I found it a little bit odd because there is no Helm downgrade command. There is only Helm upgrade to a version that happens to be lower than your current version. And even though that's not technically an upgrade, that's what Helm likes to do. Go Helm. So, yeah. There's one thing in here that I didn't really call out when we were talking about upgrade, is that there is the Helm upgrade guide. I had a link to it a couple of slides ago. Check that out. It's the place where you will find information about breaking changes or about incompatibilities that you really should be aware of before you start an upgrade. Okay. Any questions so far? I don't see any.
Everything seems to be fairly self-explanatory.
Awesome. Okay. Debugging Linkerd. We don't often like to really admit this, but at the core of things, Linkerd is really just another Kubernetes workload. So all of the things that you use for typically debugging Kubernetes workloads will actually work with Linkerd. So for example, kubectl events, you can go through and watch to see what's going on. You can go look at the logs with kubectl logs. An interesting point here is that you can also use kubectl get to show you status information. This is especially relevant for gateway API resources, and it's becoming more relevant, so bear that in mind. It can also be really useful for things like cert manager resources, update various things that kubectl get will show you, for example. And so that can be a big win. Probably nobody needs the official documents for kubectl get, but since every other slide in this section has a link and a QR code, I had to have a link and a QR code. So there you go. The official docs for kubectl get. They're much longer than I expected them to be. Linkerd CLI commands, also critical for debugging Linkerd. Some of these will doubtless be very familiar to everyone, like Linkerd check and Linkerd viz tap, and some of them may be less familiar to folks, like Linkerd diagnostics proxy metrics, or Linkerd identity, or Linkerd auth-z, which didn't exist before 2.11, and Linkerd diagnostics policy, which only started existing in 2.13, both of which can be really, really useful. Neither of which we're going to show in this particular demo, but if you go look back at the dynamic routing and circuit breaking SMA, which I really should have put another link on this one, but I only had room for one. Anyway, if you go look at the circuit breaking and dynamic routing deep dive SMA, that was from last month. We talk a bit more about Linkerd diagnostics policy in particular. Finally, it is possible to change the proxy's log level. You can do this. I'm not actually going to run through all of these. You can do it in Helm. You can do it with an annotation, which of course requires you to roll the workload and such afterwards. You can do things at runtime with kubectl port forward and curl, which is a particular scary way to arrange for your cluster to be not really in a controlled state anymore, but it works. Just remember to put it back when you're done. If you check out the documentation that I've linked to here, thank you, Jason, for linking to the circuit breaking and dynamic routing deep dive in the workshop channel. If you take a look at the documentation that I've linked to here about modifying the proxy log level, at the end of it, they point out that there is I think the word they use is non-zero negative impact on performance if you're running with debug logging, which is a beautiful way of saying, if you turn on debug logging, your system will get slower. So make sure you put it back when you're done. If you're running in production, you probably do not want to be running with debug longer than you need to be. Okay. Oh yeah, you can also set the log levels for individual controllers in the control plane via much of the same things. Quick note here, the policy controller is written in Rust. So when you change its log level, you need to use the Rust formatting for setting the level, and other things tend to be in Go, and so you need to use Golang formats just to make that much more surreal than it would otherwise be. I've linked here to the Helm templates in case you want to take a look at those to figure out how to change the log level for specific individual controllers in the control plane. All right. Jason, anything else you wanted to add here? I'm picking on Jason a lot because since he spends a lot of his time on the sales side of the world, then he tends to interact more with customers in dangerous, tight situations needing to debug things. So it's
No,
not
yeah,
cheating.
these are important things to understand how to do, right? And that's kind of the core of it, right?
Yep, very much so. Okay, one more thing here. The Linkerd debug sidecar. There's documentation about this. I'm not going to talk too much about it here. I think we used it in the MTLS, most recent MTLS deep dive a little bit. It's basically a container that we ship that just comes with tshark, TCP dump, LSOF, and IP route 2, which can be really handy for going and looking around at some of the details of what's happening in your cluster, as long as you were running in an environment where that container can have the necessary capabilities that it needs to be able to go and run all this stuff. Some runtimes simply don't permit this, so it could be it's not always going to be useful, but where it's useful, it can be very useful. Okay, so that's how it's done. Or, of course, you can cheat and use Buoyant Cloud, and some of this stuff will be easier. That QR code is a link to get a demo of Buoyant Cloud. It's a good thing to do. All right, it's almost workshop time. A couple of things I wanted to point out. We've talked about a lot of stuff that is just kind of out of scope for a workshop, at least for a workshop that we want to get finished in any sort of finite time. So we're not actually going to show setting up a proper off-cluster CA, although I'm a little bit optimistic that we'll be able to show that next time around. We're not going to show how to set up an external Prometheus. We're not going to show configuration and version control. These are mostly things that you can go look at other SMAs to find out about. We're mostly going to show an HA install with Cert Manager set up to manage the identity of your certs. I'll show a little bit of Buoyant Cloud. I'm going to show some things about debugging, and we'll talk at various points about some of this other stuff. And of course, if you have questions as we go, post them in the workshop channel and we can tackle them. All right, now it's actually workshop time. Everybody cross your fingers, pray to the demo gods, whatever. We are going to start this by installing Cert Manager. We have an empty cluster here, and it has literally nothing in it. I set it up beforehand. It's a SIBO cluster. So let's go ahead, get the JetStack repo in there, make sure all of our repos are updated, which they are, which is good. And now we're actually going to install Cert Manager. This is pretty much out of the JetStack quick start. No particular magic here. This always takes a little bit of time. If anybody has questions, now's a perfect opportunity for some.
Well, if there are no questions, I can share. Oh, are we already done?
It's okay. Go ahead.
We've got a terrible networking joke for everybody out there.
Okay, wait. Well, you'll have another opportunity.
You want me to save that? Fine.
Yeah, you can save that. All right, so we got Cert Manager going. We are now going to do the most non-production thing in our Linkerd in production workshop, which is that we are going to set up a horrible self-signed trust anchor and save it in the cluster, which is exactly what we said not to do. And yeah, I'm sorry about that. I'm actually so ashamed of this that I'm going to hide most of the details behind this non-prod trust anchor bash script. But that script is committed and pushed to the GitHub repo, so you can go and look at all the gory details. They're not all that gory. It uses step to create a self-signed cert and then uses kube control, secret create, and things like that. So off we go. At least it runs quickly. That's nice. So it leaves behind a TLS secret called Linkerd Trust Anchor. And, again, there's no particular magic to that. It's just a Linkerd secret, or sorry, just a kube TLS secret. And it also leaves behind a cert manager issuer. We'll look at this one. We'll actually look at this issuer. What's basically going on here is we have an issuer whose name is Linkerd Trust Anchor. It lives in the Linkerd namespace. Don't do that. And it will issue certificates using the Linkerd Trust Anchor secret as the CA for the certificates it issues. To do this for real in production, you would still have an issuer called Linkerd Trust Anchor, but you would set it up very differently. Instead of just saying ca.secret name here, you would tell it things like, oh, I want you to use Vault to go and get these things, or, oh, I want you to use Venafi, or whatever. There are docs about that all over the Cert Manager site. It is out of scope for this particular workshop, so we're not going to talk too much about that. We will talk about how to use Cert Manager, how to tell Cert Manager to use that Linkerd Trust Anchor issuer to create the identity issuer certificate that Linkerd needs. So there's a lot in here. The highlights, the name of this thing is Linkerd Identity Issuer. The common name of the subject this is the common name that will go directly into the certificates that are created by this certificate. Since we're going to use this for the identity issuer, it must be named identity.linkerd.cluster.local. We explicitly set it up so that those are the only DNS names it has. The rest of this stuff we talk about more in the certificate management SMA. Sorry about that. Worth noting, we're only going to let it live for 2 days. It's 2 days, and we're going to make sure that we renew it no more than 25 hours after it's issued. And also, we specifically point out that we're going to use the Linkerd Trust Anchor issuer, and that the private key needs to be stored in the Linkerd Identity Issuer secret. All of those are important for linking this back to the linking this back to the Cert Manager issuer that we just created, and putting it in a place where Linkerd can actually find it to use it. So we're going to apply that. And if it did its job, that's good. You remember I mentioned that kubectl get actually tells you useful things. So one of the things that happens for Cert Manager certificates is that when you do a kubectl get on a certificate, then it will tell you whether that certificate is ready to use or not. And it will also tell you which secret it's referring to. So in this case, we can see that it is ready, and it's written it into the Linkerd Identity Issuer secret. If we go and take a quick look at that, then yeah, it's a TLS secret off and running. Once that is done, we have certificates that we can use to install Linkerd, and we want to install Linkerd in high availability mode. So as we mentioned in the slides earlier, we're going to start by grabbing the Linkerd control plane chart, and we'll take a look at values.ha.yaml. A lot of this is stuff where it's probably worth reading on your own, but some of these that are particularly important are: we explicitly enable pod anti-affinity to make sure that we're not going and putting 2 control plane replicas on the same node. We explicitly go through and make requests for the proxy, and then we make a different set of requests for all the resources, all the controllers in the control plane, and all that. So there's a fair amount of stuff in here, and you may find, especially if you're doing higher traffic stuff, that you need to go and edit some of these resources. But there's no particular magic in here. It's just a values file for Helm. If you want to, you can go take a look at this and then go look at all of the templates in the Helm chart, and you will find all the secrets for exactly how it works. All right, given that we have that, then we're going to go ahead and install the Linkerd CRDs with Helm. And then we're going to go ahead and install the Linkerd control plane itself using Helm. Couple of things that are different here from the way we normally do this. we explicitly tell Helm that there is a file called ca.crt in the current directory, and that is what it should use for the identity of the trust anchor. That's kind of awkwardly phrased, but yeah, it's really a better way to say it is that is the public half of the trust anchor that the identity part of the control plane will be using. And we are also explicitly telling it that there is already an identity issuer present in the cluster as a kubernetes.io/tls secret. Those two things permit Helm to work with the things that we already set up for the trust anchor and the identity issuer. It is possible that you'll have to tweak this to use a proper, so that should say off cluster CA rather than off control CA. I'll have to fix that afterwards. So off we go. And now Helm says everything is good, so we're going to run Linkerd check and wait for everything to go. And now, Jason, if you really must, you have another opportunity for your truly horrible networking joke.
Right. Yeah. So good time for questions if anyone has them. One person
better
was
than the
asking
joke.
about the tool that you're using, and so we did link to that Dimash tool one more time.
Nice.
And since I haven't seen any movement yet, I have a networking joke for you, internet people. So I have, in particular, a UDP joke for you. You may not get it.
I think the next time we do this, I'm going to have sound effects set up. I'm not sure how to do that, but there's got to be a way I can put some sort of raspberry or sad trombone or something like that. I got to figure out a way to do that.
And my salesperson's so tired of it that he bought me a book of computer jokes. So I would do something else. I won't.
Okay, a couple of things that are interesting here. Notably, okay, fine. I'm using 2.13.3 instead of 2.13.4. Fine. Yeah, okay. And the other thing that's worth noting here is the issuer cert, which is deliberately set to 2 days, is not valid for at least 60 days. That's good. And oh dear, I forgot to put that annotation on. You know what? I'm just going to run with it and we'll see what happens. So it's increasingly likely that I've done more than one thing. That's not the way you want this for production. Okay. We can verify that we really do have multiple nodes here. We do. We have 3 of them, which is great. And we can verify that we have multiple replicas for all of our things. If you look carefully, it's easiest to see with the destination controller where there are 3 of them, but we have 3 proxy injectors and we have 3 identity controllers. And if we're paranoid, we can run this fairly hideous looking thing and have it go through and tell us that, okay, if we look at our destination controllers, all of them show up on different nodes, 1 per node. We can repeat the same thing with the identity and the proxy injector, but I'm not going to bother. So HA mode seems to be doing its thing, which is good. And off we go. So given that we've now installed this in HA mode and Cert Manager is handling the identity issuers, then this is pretty much it in terms of installing Linkerd itself. The next steps would be installing an application and setting up policy and doing all of this stuff. We're not going to dig into that too much, but we will install Emojivoto in its brain dead, simple way, just to kind of have something that we can look at a little bit. That error message is really just complaining that we haven't applied that particular set of resources before. I would love to find a good way to make that go away. All right, let's wait for Emojivoto to be ready, which should be fairly quick. Should. I might actually go ahead and, you know what? Never mind. I'm not going to go ahead and put that label on. At this point, I'm just kind of curious what exactly is going to happen. All right, I just didn't quite give it enough time there. Okay, onward. So we can start, if we want to get a sense of what's going on, we could just look at events. Here I'm looking at events in the Emoji Boto namespace, but I'm also curious for interesting things that relate to Linkerd. One of them that's kind of interesting is, you see that issued leaf certificate thing? That's actually coming from Linkerd, where it's saying, hey, I've gone through and issued you a certificate. We can also see, oh, look, we have proxy containers getting started, things like that. Those issued leaf certificate events are particularly kind of interesting, where I'm a little curious to see if we have everybody with one of those. And so we can use this to look for only events with a reason of issued leaf certificate in the Emoji Boto namespace. And hey, look, we see each of our 4 workloads in that namespace are indeed getting a leaf certificate, which is kind of nice. We can also take a look at the logs. And here we'll start with the Linkerd identity controller. There are several of them. That just gave me the first one, but that's okay. I only want to look at one of them right now. And we can see things in the logs here where Linkerd identity is talking about issuing certificates, which makes sense because its purpose in life is to manage workload identities. So we can also, if we scroll up a little bit, this bit about containers, there are multiple containers in that pod. We've got the identity container, the Linkerd proxy container, the Linkerd init container, all of which have different functions. Identity is the container that embodies the compute part of the identity controller. The Linkerd proxy is managing data traffic in the data plane, and Linkerd init is the init container that went through to wrangle everything in the network when we started. So if we take a look at the Linkerd proxy container, then it started off talking through a bunch of stuff. It talked about its local identity, which is kind of nice. It gave us some random errors about being unable to resolve things. I did a head-10, so I'm just looking at the beginning of the logs here. And so seeing some errors with stuff like this, you may see things like this because Kubernetes is only eventually consistent. And so it can take a little while for some of these things to get properly started. If you see that stuff persist, that is a problem. We can also take a look at the init container, and we see it going through and doing a bunch of IP tables stuff, because that's the purpose of the Linkerd init container, is to go through and mess with the networks. For most of these, the general output that you will see can look verbose and incomprehensible, but they're all pretty good about making it plain when something has gone wrong. And that's the important bit there. All right. Any questions so far? Doesn't look like it. Cool. Okay, so we're also going to take a look at one of the logs for one of our Emoji Boto containers. Pick the same thing here. We're going to look at the emoji service pod. And if we do this, interestingly enough, it defaulted to the Linkerd proxy container, which is very likely not what I'm interested in looking at if I'm trying to debug the emoji service itself. So it's worth remembering, you might need to go through and explicitly specify the container that you want when you're actually trying to debug an application workload. Although it is kind of nice to see the identities that this one is using. Nice. And here we can see that the emoji service doesn't actually do anything terribly interesting in its logs, but I happen to know that this is what it looks like when all is running. Okay. We're going to take a quick look at a couple of other things here as well. We're going to look at Linkerd identity, and we're going to look at Linkerd diagnostic. Linkerd identity basically gives you a way of asking Linkerd the specifics of the identity that it is using for a given workload. And this is often useful if you think things are going wonky with certificate handling, or if you're just trying to verify exactly what's going on there. So here I'm going to run Linkerd identity. I'm going to look in the emojivoto namespace, and I'm going to look at everything that matches the app equals emoji service label, which happens to just be the one pod that we looked at a second ago, but whatever. And if I look at that, I get an entire X509 certificate that is the public half of the identity certificate for that particular workload. That's what its proxy is using every time it does an MTLS connection. If we just look at the things that have CN equals in it, then we can go through and see that it is using a subject named emoji.emojivoto.serviceaccount.identity.linkerd.cluster.local, and that it was issued by identity.linkerd.cluster.local. There are two things that are useful here. One of them is that, oh, good, identity.linkerd.cluster.local is actually the name of the Linkerd identity issuer. So this certificate came from the right place. The other one is that when you go through and you're trying to write policy about this, you got to use that whole emoji.emojivoto.serviceaccount.identity.linkerd.cluster.local name when you're writing policies. So it can be very helpful to be able to get exactly the name of the thing that you want to use for policy. Also, obviously, if you run this and you get something you don't expect, then that can explain why things are going wrong. At one point with the faces demo, I could not get policy to work and ended up running Linkerd identity on one of my faces pods and found out that, oh, I hadn't actually assigned it a service account. So they were all running with the same default service account, which meant that there was no way to distinguish between them from Linkerd's point of view. So that was a case where in the real world, it actually showed me a bug in the way I'd set up my application while I was trying to get something done with Linkerd. As an aside, the control plane components also have identities. They are fully meshed. If we look at the identity component of the control plane, first off, you'll notice we got 3 different things back here because there are 3 different replicas. But you'll also notice that they all say the same thing, which is very nice. If they did not all say the same thing, that would be very confusing, and we would be very, very curious to figure out how you set things up that way, because I don't know of any way to do that. That would be fascinating to see. So if you get into that state, ping me on Slack and let me know. I'd love to hear how you did it. All right. One more look here. We're going to look at Linkerd diagnostics. All right. Linkerd diagnostics is an interesting, powerful, and complex command. There are 4 different things that it can do. We're going to look at 2 of them and talk about the other 2 a little bit. Linkerd diagnostics proxy metrics fetches low-level metrics directly from the Linkerd proxy without requiring them to go through something like Prometheus. Linkerd diagnostics controller metrics does the same thing, but it's looking at control plane things rather than proxies for your application. Worth noting, you can get proxy metrics for the control plane controllers. I'm not sure why you would necessarily want to, but you can do it. Linkerd diagnostics endpoints will show you exactly what endpoints Linkerd believes are alive for a given destination, which can be particularly important if you notice things like, hey, 2 of my pods are getting all of my traffic. What's going on here? And finally, Linkerd diagnostics policy in 2.13 and later will show you about all of the active 2.13 policy stuff. Fair warning, most of these are extremely verbose. So get used to filtering the output somehow, grep, or dumping them into a file and searching, or writing programs to parse them, or something like that. So we're going to start with a really simple one. Endpoints that are active for the emoji service. There should be exactly one of these because there's only one replica here. And look, there's one of them. It tells us the IP address. It tells us the namespace of the thing. It tells us which pod it is. It tells us the service that maps to it. But there are 2 really important things about this. The first one is only the active endpoints are shown. So if one of your replicas has fallen into failfast, then it's not going to appear. That's what makes this a particularly useful debugging tool. Another thing which makes this a little bit possibly less useful is that policy is not taken into account here. So it is possible to use an HTTP route to take all of the traffic going to the emoji service and route it over to a different cluster, and we will not see that reflected in Linkerd diagnostics endpoints. It will still show us that there, hey, there's one active endpoint for this, despite the fact that the HTTP route will prevent any traffic from actually reaching it. One other thing that I did not, let me back up. Linkerd diagnostics policy does show you about that. So the information is available. And the other important thing that I should have written here is that this is a fully qualified DNS name for that service. That's why it's written out as emoji-service.emojivoto.service.cluster.local. And you also have to specify the port that you're interested in as well. Oh, wait, I did put that in there, and then I forgot I edited it. Like I said, doing this live, folks. Yeah, great. All right. We will take a quick look at proxy metrics. So this is basically saying, go directly to the pod that we found earlier for the emoji service in the emoji voter namespace, grab all the proxy metrics and spew them out on standard out. This goes on for a long time. But there's an enormous amount of information you can get out of here if you want it. I'm not actually going to page all the way through that fire hose because there is a ridiculous amount of information there. But the huge win here is that you don't need Prometheus or Linkerd Viz or anything else running to be able to access this. The astute observer of this SMA will realize that we never even installed Linkerd Viz. It's not running in the cluster right now. The metrics are still there. If I want to, I could write something that takes Linkerd diagnostics proxy metrics output and just grabs the specific things that I care about and shows me a success rate or whatever. In almost every case, it's much more valuable to do that with something like Prometheus and Grafana or Buoyant Cloud. But, you can do it directly if you really need to. And maybe more importantly, if you're having trouble with Prometheus, then this can give you a lot of information about whether somehow the proxies aren't producing the information or whether your Prometheus scraper isn't working or whatever. This is another place where I'm going to put Jason on the spot. Anything you wanted to add to this so far?
No, that's exactly what I use it for, right? And that's what I see folks using it for in the wild, is just to check if you're not getting the data into Prometheus, are the proxies outputting what you expect them to put?
Quick question. Have you ever seen the proxies not outputting stuff? Or is it pretty much always the scraper doing something wrong?
I have not seen it yet, but you never know.
It could happen. Somewhat less facetiously, it could certainly happen, for example, that you realize, hey, there's no proxy for this thing because you screwed up meshing it or something like that. Okay, we are not going to show diagnostics controller metrics today because it basically is like proxy metrics just for controllers. And we're not going to talk about Linkerd diagnostics policy because we go into that in the deep dive on inter-route-based policy. And possibly the dynamic routing and circuit breaking thing that Jason already linked to. Actually, I think it is the dynamic routing one. So let me make myself a note to double check that and fix it. All right. So that is a quick wrap on the demo of production Linkerd there. And now is a great opportunity for questions. We're going to go and show a little bit about Buoyant Cloud as well. And that'll be much more fun than, well, that'll be particularly interesting because I'm kind of fascinated by the fact that my cluster is running 2.13.3 instead of 2.13.4 right now. So that's going to be interesting or something like that. Questions?
Yeah, no, you're good on questions,
Okay.
folks. If you have anything, please don't hesitate. I'm happy to share with Flynn, or we can always answer you in line in Slack.
All right. So, ooh. We're going to have to go through and edit that to not show those things, I think. All right. So this is Buoyant Cloud. We're looking here at a view of all of the clusters that I have access to right at the moment. I'm going to point out here, full disclosure, there is a free tier of Buoyant Cloud, and I am not using that. I am using the non-free Buoyant Cloud tier because it's cooler, and also because I work for the people who make Buoyant Cloud, and I think it's really nice to have people pay us, and so they can pay me and things like that. So yeah, this is not the free tier of Buoyant Cloud, but y'all should definitely check it out. Okay. It's going to be fun, I think. All right. So what we're going to do here is we're basically starting with how we link up this cluster to Buoyant Cloud. And we're going to start by installing the Buoyant Cloud agent. The agent needs a couple of values from the add a cluster option in add a cluster command in Buoyant Cloud. I have saved those in cloudvalues.yaml, but I'm not going to show you those values because they are sensitive, actually. One of the few things about this place that are kind of sensitive. So let's install that. While that is going, I've now gotten this set up so that we are waiting for the agent to connect to Buoyant Cloud. I guess it just did. Nice. Okay. So it amuses me that it's doing that before the Helm install finishes. So that's always entertaining. Now I can't resist. Let's go see what other stuff is going on in here while it's actually still. Yeah. So it's finished enough that it got a connection from the agent, but it's not finished enough to know anything about the cluster, anything about what's really going on. So, all right. All right. I just figured out I also just figured out why I was getting warnings about 2.13.3 instead of 2.13.4. That's because my Linkerd CLI is still 2.13.3. My cluster is correctly running 2.13.4. I feel much better now. So now we have a little bit more information available. Oh, there we go. Just finished. So let's go ahead and take a look at the cloud dashboard, the cloud console. I've picked just my SMA cluster here. It can go through and show me a bunch of things about the control plane. It can go through and show me some things about resource usage and whether Linkerd is healthy and all this kind of stuff. It can show me, oh, hey, I'm running stable 2.13.4 and Linkerd is okay and we're not doing any management of it yet. If I look specifically at the control plane, I can see things about MTLS certificates. My trust root expires in 10 years. Probably also not a great idea in production, but I think that rotating it more often than that's probably a good idea. I can take a look at the webhook certificates, which we haven't really done a lot of talking about until the next SMA. I can look at the data plane and see that I've got a bunch of proxies running on my data plane, none of which are managed. And one of the things that I personally think is kind of cool is that I can take a look into the various topology of my cluster and watch what is communicating with what. It's always kind of interesting to be able to go through and zoom in on a particular namespace as well. So the specific thing that I kind of wanted to show here is using cloud to actually manage versions of Linkerd. So what I'm going to do here is I'm going to apply this control plane resource that tells Cloud, hey, I want to be running Linkerd version 2.13.4. And I'm going to create two data plane resources to tell it that in the Buoyant Cloud namespace and the Emoji Butter namespace, I would like for Buoyant Cloud to be able to keep workloads in those particular namespaces up to date when I change the control plane. So we'll apply both of those, and hopefully we will get to see things changing. So you see now up to date. Great. If I go into the data plane, I see that all of these are now managed. Proxy version stable 2.13.4, everything is up to date. This is good. This is exactly what I wanted to see. Now, this is the part that'll be fun. I'm going to now try rolling this back to 2.13.3. Everybody cross your fingers. So I've changed the spec.components.linkerd.version field in my control plane resource, and that is the only thing that I'm going to change. Switch back here, and we give it a minute. Oh, I suppose so. Aha, you can see that we now suddenly have some 2.13.3 proxies in existence. I'm looking at the data plane now, but you can see here 2.13.3. Look at the control plane. It is updating, and it's showing me that, oh, look, I've just had all my proxy injectors start running, which is nice.
If you head on over to the overview tab and go to the bottom, you'll see events associated with the rollout occurring down at the bottom there.
Oh, nice. This is the other reason to have Jason on these calls, because he can go through and point out things like that.
Also on the left-hand side under that resources tab, you can get into the whole manage Linkerd section.
Which candidly is slightly less interesting for what I want to do right this second, but it's still very interesting because it tells me in particular that the current version is 2.13.4, it's going to 2.13.3, and it's still updating. I personally tend to like this one a little bit better because I get to watch and see what exactly is going on. Okay, there we go. So in a minute, I expect to see this switch back to up to date. Up to date, perfect. If I look at the managed Linkerd resources now, I'm running 2.13.3. If I look at the data plane, we still see 2.13.3 and 2.13.4. It's going to, you can see things like this changing. That is going to take a little bit longer to go. I'm not entirely sure how much longer I'm going to wait for it, but you can see that it's doing the right thing there. That's the main thing that I wanted to show with Buoyant Cloud at this particular moment, was just a quick demo of one of the cool things about cloud with production is how easy it is to go through and just say, hey, give me this version and let it do all the hard work for you. That's really nice, actually. And being able to have it do things like show you whether any of your certificates are wrong. There is also in the workloads section, we get to see all of this stuff, whether it's meshed, whether it's managed correctly. Jason, you're going to have to help me out here. There is a way that I can ask it to show me if any of the trust anchors are out of date.
So it'll warn you very loudly if things are getting out of date. It'll also tell you on each proxy what its certificate states are.
Right.
And the nice thing is it warns you before things go out of date also.
Which is a huge win. Lots and lots and lots of events associated with this update. So, all right. And that will do it for a whirlwind quick tour of how, no, really, Buoyant Cloud makes a lot of this stuff easier when you start dealing with this. Anything else?
We have
from
a question
anybody.
from Vito about is there like a best practices document for setting up your alerting and things? Just to
There,
answer. Oh,
go
sorry. Go ahead.
ahead.
Yeah, I was gonna say, to answer Vito's question, the Linkerd production runbook is the source for stuff like that, right? So that's the basic recommendation in general, right? When you're looking at your control plane, you want to see, where am I at resource utilization versus my resource limits, right? Obviously, that's a pretty critical one to keep in mind, right?
Yeah,
Because you don't want to be
just a
bumping up
touch.
against those limits.
Yeah. Um, you also do want to take note of things like, you know, monitoring for certificates expiring is really a big deal, even if you have something like Cert Manager in play. Um, monitoring for, are you running the versions of things that you want to be running or that you think you're running, can also be a big deal as well. I have definitely seen problems in the real world where people would come over and say things like, "Why is this not working? I'm trying to do X, Y, and Z. It's not working." And you find out, oh, that's because you only thought you upgraded to 2.13. It was a different cluster. You're still running 2.9 in production, and that feature is not supported. There are a couple of people, or at least one person typing, so I guess we can hold on for a minute here. Questions, comments, heckling. Okay, maybe not heckling, but questions and
Right.
comments are definitely welcome. Best practices for CNI or Linux customizing to have better service mesh with Linkerd. Um, I think, Ziad, I think what you're asking there is, are there best practices for maybe which CNI to use, or is that what you're getting at there?
While we're
While we're
while we're
waiting,
waiting. Oh yeah.
yeah,
Go
Alejandro
ahead, Glenn.
Baeza, special considerations for multi-cluster. Certificates become much more important, and you have to monitor each cluster independently. I shall once again shamelessly plug Buoyant Cloud, because if you look over here at this dashboard, if I come up here, I've got several different clusters. I'm not going to actually look at any of the other ones, but actually I can just go over here, right? So we have several different clusters already linked up with Cloud, so Cloud can be watching all of these at the same time for us. I feel compelled to point out that the two that are logged that's not responding are because we deleted them. Yeah, so yeah, so I guess Jason didn't actually click the remove from this thing, right? But yeah, there we go. That is one of the other nice things about Cloud, is that it can watch multiple clusters at once. If you're not using Cloud and you are using multiple clusters, then yeah, make sure to monitor each of the clusters, because things can get very confused if one of your clusters gets sick and you don't notice that it's only one of them. I guess another one that's worth noting is the link resources might also be a good thing to monitor, to make sure that you have bidirectional links where you want them and things like that. Anything else come to mind from you there, Jason?
No, yeah, certificates, the health of those links. That's really the big one.
Yeah.
Um, so Ziad is asking about a particular CNI. We don't have, like, we're not going to tell you use one CNI or another, right? Like, from our perspective, we're a consumer of the network, whatever that may
Yeah.
be. So I think about what's easiest and makes the most sense based on your use case, right? Would be my recommendation.
Now, that being said, if you find a CNI that we crash and burn with, let us know, because we are a consumer of the CNI. We think we should work with whatever CNI you want to use, pretty much. Um, I'm sure there are exceptions out there, but I can't think of any off the top of my head. Just, it ought to work.
Yeah, no particular Linux customization that we'd recommend, right?
Mm,
Um,
thank you. I missed that one. Or rather, I
we're happy
forgot
with
about that one.
Kubernetes in general.
Yep. I think I saw another.
All right, well, I think we're ready to wrap up here, Flynn.
I see one other person typing. So we can wait for another 30 seconds or so.
Okay.
No pressure.
No pressure.
Is there a way to measure your memory and CPU limits for a service?
Yes, absolutely. There is a way to measure it. Setting up your own monitoring. Again, if you're using the Buoyant Cloud commercial project, it's got that built in for you. Otherwise, setting it up for your own monitoring system is going to be like out of scope for this particular workshop.
There is one thing that comes immediately to mind is you can always do things like this, and it will tell you, okay, so emoji is using 5 millicores and 20 meg of RAM. And then if I turn around and look at the deployment for the emoji service, I can see what it's requesting. So that's a really simple, trivial way of looking at things like that.
Yeah.
Measuring bandwidth and traffic for each service. Yeah, that's a little trickier, honestly.
Well, it's Linkerd will give you that
Yep.
view of your environment.
I was about to say I would start by firing up Linkerd Viz or by firing up Buoyant Cloud. But Jason beat me to it. It's tricky. If only there were a tool that could help you with such things. Oh, wait, we have one.
Yeah.
All right.
And thank you to Maria for linking to the production run book.
Oh, yeah. Nice. Thank you very much. Okay, so with that, a couple more slides here. Yes, we showed Buoyant Cloud. Go and take a look at a demo and do awesome things with it. Will wants more jokes and hair flips. There you go. I got no more jokes for you, though. Jason needs some Linkies. Yeah, Jason, you do need Linky on your shelf. What's wrong with you, man? Fortunately,
Shelf's
Jason,
a work in progress right now.
Fortunately, Jason can get a Linky on his shelf. Next SMA, we're going to go back into a deep dive into certificate management. It'll be back here. Sign up at buoyant.io/SMA. Let's see, what else do we have? The Linkerd forum. Rather than posting your questions in Slack and having them get deleted every so often, you can now join the forum and they won't get deleted and people can search them and good things will happen. So check that out as well. Excuse me. That was not an editorial cough. I actually literally had to cough. Finally, we also have the shiny new Fundamentals of the Service Mesh course. I'm a little surprised that the URL is not there by the QR code. It is learn.buoyant.io, which I shall put in here in the workshops channel, just in case anybody wants to get at it that way. And with that, I believe that is it. Many thanks to everybody. Much appreciated as always. And we'll be here next week, or sorry, next month, not next week. Last chance for questions before we turn everything off. All right, I think we're done. Thanks much, everybody. Appreciate it.